13 against 27 over Chungking, 1940. And when it ended, only the 13 flew home. In October 1937, the Imperial Japanese Navy asked its aircraft industry for something close to a contradiction. It wanted a carrier fighter, light enough to launch from a deck, tough enough to survive a slammed arrested landing, compact enough to ride a ship's elevator. And it wanted that fighter to outrun, outclimb, and outturn every land-based fighter on Earth, while hauling 2 heavy cannon, 2 machine guns, a radio, a navigation set, and enough fuel to stay aloft for the better part of a day. Every line of the specification fought every other line. More fuel meant more weight. More guns meant more weight. More weight demanded a bigger engine, and a bigger engine was heavier still, and Japanese engines of the period made 20 to 30% less power than their Western equivalents. The requirement asked for a machine that the laws of aircraft design said could not be built. 2 firms were invited to try. Nakajima, one of Japan's most capable manufacturers, ran the numbers, declared them impossible, and withdrew. At Mitsubishi, a 34-year-old engineer named Jiro Horikoshi looked at the same numbers and saw a path. Horikoshi was not working alone in a shed. Behind him stood the Mitsubishi Empire, a sprawling industrial group founded by a former samurai in 1870, grown across 70 years into shipyards, coal mines, steel mills, banks, and the largest private company in the country, Mitsubishi Heavy Industries. Its aircraft division ran out of the vast Nagoya Works in central Japan, with thousands of engineers and assemblers and the deep resources of a true industrial giant. But infrastructure could not repeal physics. Horikoshi had already designed the Navy's previous fighter, the A-5M, and made his name as the finest fighter designer in Japan. He knew the new specification could only be met one way, and he knew exactly what it would cost. The answer was weight. If the engine would always be weaker than the enemy's, then the airframe had to be lighter than anything the enemy thought possible. Light enough that the engine's disadvantage simply stopped mattering. So Horikoshi went looking for weight to remove, and he found it in the one place every other designer in the world was busy adding it: protection. He left out the steel plate behind the pilot. He left out the armor around the fuel. He refused the self-sealing tanks that American and British engineers were treating as essential, the rubber bladders that close a bullet hole before the fuel pours out and the aircraft becomes a torch. Every Western fighter on the drawing board was gaining these things. Horikoshi deleted them before they were ever drawn. The rest of the design was an exercise in the same discipline. He built the structure from a new high-strength aluminum alloy that let every rib and spar be made thinner. He ran a single continuous spar through the wing and built the fuel tanks into the wing itself. He joined the fuselage in major sections with a ring of bolts so that engine, cockpit, and wing formed one rigid, lightweight unit. The empty aircraft weighed about 3,700 pounds. The American carrier fighter it would soon face, the Grumman Wildcat, weighed nearly a ton more. That gap was not luck. It was Horikoshi's entire argument, made in aluminum. The prototype first flew in the spring of 1939. The numbers that came back were not just good, they were unprecedented. Top speed passed 330 miles an hour, a climb that hit the Navy's most punishing target almost exactly. And range, with a drop tank well over 1,600 miles. That belonged to a bomber, not a fighter. The Navy accepted it in 1940, the Japanese calendar year 2600, and the last 2 digits gave the fighter its name, the 0. Then it went to war, and for 6 months it owned the sky. At Pearl Harbor, some 78 Zeros swept American fighters from the air over Oahu. The same day, and in the weeks after, they shredded Allied air power over the Philippines, Malaya, the Dutch East Indies, Burma, and Ceylon. Buffaloes, Warhawks, Hurricanes, nothing in the Allied inventory could fight a Zero on the Zero's terms and win. Historians put the kill ratio of that opening stretch at roughly 12-1. The pilots flying it, men like the ace Saburo Sakae, described the machine as an extension of their own bodies, so light on the controls that the line between aviator and airplane dissolved in a turn. The intelligence officers who had laughed off the reports from China were now writing new reports over their own burning airfields. But Horikoshi's bargain had a back page, and the war eventually turned to it. Every gram he had stripped away to win the turn was a gram of protection the pilot no longer had. The same design that made the Zero untouchable when it attacked from above made it lethally fragile the moment it was hit. A burst that a Wildcat could absorb and carry home would open a Zero's unprotected tanks, and the fuel would pour and the aircraft would burn. A single round into the cockpit from behind could kill the pilot through armor that was not there. It was a sword with no shield. Magnificent while it held the initiative, catastrophic the instant it lost it. The Allies learned to stop fighting on the Zero's terms. They refused the slow turning fight, used altitude and speed, dove in and extended away. A tactic called the Thach Weave let two fighters cover each other's tails and cancel the Zero's agility outright. Then, in June 1942, a Zero crash-landed nearly intact on a remote Aleutian island. The Americans recovered it, repaired it, and flew it, and for the first time measured exactly where it was strong and exactly where it was weak. Slow in a high-speed dive, sluggish in a fast roll, fragile under stress. Diagnosis complete, the United States built fighters designed around those weaknesses. The Hellcat and the Corsair arrived in 1943, heavier, faster, armored, self-sealing, with engines making more than double the Zero's power. By the middle of that year, the Zero was no longer the best fighter in the Pacific. It was not the second best. Horikoshi had successors on the bench, but Japan's industry, bombed, blockaded, starved of raw materials, could not build them in time. By 1944, the Zero was obsolete and flown increasingly by half-trained boys, while America's pilots downed them in numbers that earned battles names like the Great Marianas Turkey Shoot. And from late 1944, the Navy began strapping a bomb to the fighter and aiming it at American ships. More Zeros were spent as kamikaze than any other aircraft. The most agile fighter ever built ended its life as a guided missile. Horikoshi was privately shattered. His diary, published much later, shows a man who believed the war was suicidal from the start and watched his creation consumed in a defeat he had foreseen. In total, more than 10,000 Zeros were built, the most produced Japanese aircraft of the war. When Japan surrendered in 1945, the occupation dissolved the Mitsubishi conglomerate and banned aircraft production entirely. The factories that had built fighters capable of crossing the Pacific turned to building motor scooters, buses, and three-wheeled trucks. But the people stayed, and so did the discipline. The same obsession with shaving every unnecessary gram went into a tiny, light passenger car in 1960. In 1970, Mitsubishi Motors was spun off as its own company. The engineers who had calculated loads on wing spars now calculated them on suspension arms, and the culture produced rugged, over-engineered vehicles. The Dakar-conquering Pajero, the rally-winning Lancer Evolution, that endured punishment lesser machines could not. Horikoshi lived to see it. He helped design Japan's first post-war airliner, taught and wrote a memoir of the Zero, later translated as Eagles of Mitsubishi. He received the Order of the Rising Sun and died in 1982 at 78. Decades on, the filmmaker Hayao Miyazaki built The Wind Rises around the tension that defined his life. The man who loved airplanes and hated the war they fought. Today, the Mitsubishi name spans hundreds of companies. Mitsubishi Heavy Industries alone employs more than 77,000 people and earns revenues in the trillions of yen, building rockets, gas turbines, and the naval vessels that patrol the seas Japan once tried to conquer. The line from Horikoshi's drawing office to that modern aerospace division is direct and unbroken. The Zero was not the best fighter of the war. By 1943, it was not even the best in the Pacific. Its genius and its tragedy were the same decision. A machine built for a short war by a nation that could not survive a long one. But the engineering was never the failure. The factories survived. The engineers survived. The habit of asking, "Where can I remove weight?" survived everything. The machines changed. The discipline did not.